One way for Americans to embrace alternative energy is to seamlessly integrate it into their lives.
We're here today at Brookhaven National Laboratory at the Northeast Solar Energy Research Center to test advanced solar energy technologies that will be integrated into the grid. What we're testing is how the electricity is delivered from solar and renewable energy resources to the electric grid. Reliability is a key thing for the utilities. They have to be very sure about new technologies and how they're going to behave when they're integrated into their system.
One of the problems you face with arrays like this is that the power that it generates is variable. When clouds come over, it blocks the sun, the power goes down. Clouds move away, power comes back up. So you might see this variability in the grid, which can do bad things to the loads on the grid. You don't want your lights going on and off when the power fluctuates.
Getting a consistent flow of electricity is similar to traveling on the expressway.
So you can think of the electricity being delivered from a solar farm onto a utility wire. The electrons that are coming out, they have to get onto that highway, if you will, and they have to come in at the right time and in the right phase. If they're out of sync with the other electricity that's flowing, then they may cause a little reaction there that you don't want.
BNL is also working on improving solar panel technology.
When the Long Island Solar Farm was built in 2011, the project was fitted out with solar panels of the same size as these panels here, and they were roughly 250 watts per panel. Over here, each panel is a little over 300 watts.
This solar array is designed to conduct multiple studies.
We've purposely built in a number of flexible type of design options. You'll see some cable trays that we have that are above ground here. This is to make the wiring more accessible in case we wanted to reconfigure the array. In back of us there's an equipment pad where we could install different pieces of equipment to run tests on them. For example, different types of inverters. We could also install energy storage technology here and see how it operates in conjunction with the solar array to store energy.
Surprisingly, the generation and delivery of electricity has many complicated steps.
The panels come out at 600 to 700 volts DC. From there it goes into the inverter. It converts it to AC power at like 208 volts. This transformer kicks it up to about 418 volts, and ultimately it's stepped up to 13,800, which is the distribution voltage. There's another transformer right at the building that steps it down to 480, 240, 120.
This array can produce up to 500 kilowatts of power. The average home uses anywhere from 5 to 10 kilowatts, so there's enough energy here to power up to 100 homes. But we won't solve our energy needs until we change the way we consume electricity.
What everybody does is they take these and then they put them into what is known as an inverter. It takes the DC current and converts it to AC current. In that conversion process, you lose energy. You can really improve the efficiency of home operations if you just have all DC. Your cell phone, your computer, your television, all of these items actually are running on DC power inside. Every one of those little bricks that you have plugged in somewhere is in an inefficiency, and you can lose 5 or 7% of power in those kinds of devices.
That means that even the energy efficient LED bulbs are not as efficient as they can be, because they must convert AC electricity back to DC. One solution: don't waste energy converting.
If we could just directly go into a DC microgrid, you could actually really improve the efficiency of the system.
With more efficient energy production, more efficient energy delivery, and more efficient energy consumption, we'll be able to eliminate those old power plants and enjoy the power of these plants.